Okay, so we'll go ahead and get started here. This is week 5 of 116, and I'm going to switch over to the schedule for a minute, show you where we are. We're basically on week 5 today, and so we're halfway through the course. And tonight we're going to be talking about Chapter 3, Understanding Structure. And we'll do that, and then we'll book on over to the other room after this for those of you who want to go back over there. And then next week we'll meet over in the other room for lab time, just like we've been doing. So that's our plan. And so due dates, we've got Chapter 2 due on the 3rd, just tonight by midnight. So, and then after that, the next due date's the 17th for Chapter 3. Under the learning units, I have Chapter 3 out there, and got slides, which I'm going to save to my desktop. And then the videos. Have any of you tried these out since last time? Are they okay?
Yeah, they're a little, probably my computer, but it seems a little grainy.
Okay.
Yeah, and when you type in you type in just like the words above like the actual structure itself of the program, and we put like the comma slash whatever.
Yeah.
None of that.
Okay. At the top, you mean?
It's too light.
Oh, the gray. Oh, you mean the comments in gray?
The comments, yeah.
Oh, okay. Huh. Okay.
So,
Maybe
it
I'll.
seems like a lot of the stuff you do on the software that shows up on there, it just seems
Okay. All right. Okay. I'll crank up the size of the font. This is the Chapter 3 assignment, and there are 3 case problems, and we'll talk about that here shortly, but I wanted to just switch over to the slides and work through these first. Okay. Okay, so we're going to be talking about Chapter 3, which is programming structure, and in this particular chapter, they're really looking at making sure your programs are designed right. And there's 2 ways to write software. There's the clean way and the sloppy way, and both get the job done, but the sloppy way, it makes your code really hard to follow after you write it, and it's called spaghetti code, and it's just a term that people use, and because it's like a big plate of spaghetti, and it's difficult to follow. Whereas the clean approach, it is structured in a way that just makes it easier to read. So that's really what this chapter is about. So let's take a look at this. The objectives here are to learn about the 3 basic programming structures: sequence, selection, and loop. Every program that's ever been written uses those 3 structures, and only those 3. And so once you learn how those work, then you can tie them all together and come up with a program. You've been doing that so far, but it's mostly been just a sequence of instructions that you've been writing. So we're going to learn about that. Then this thing about priming reads, we're going to talk about that, and that involves loops, and we'll get into that here shortly. You'll see what that's all about. Understanding the need for structure, recognizing if a program is properly structured or not. And then if it's not properly structured, how do you make it right? That's really what we're going to try to accomplish here. So the 3 basic programming structures are sequence, selection, and loop. And when you think about it, a computer does 3 things, essentially. It executes a series of steps, it makes decisions, and it executes things over and over. If you look at the diagram on the left side, this is where it's just doing one thing after another, and that's really been what you've primarily been writing so far. Your programs are sequence based. Things get a little more interesting when you're able to make decisions, and so the selection structures, the diamond that you see, is where you put a question, and if the answer to that question is yes, you go this way. If it's no, you go this way. And actually, you'll usually write no and yes above the lines. And then, of course, whatever comes next is what you decide to do. So, for example, if the light is yellow, double your speed to get through it. If the light is not yellow, then what would you do next? You'd ask, is it green or red? So you can nest questions inside of each other, and that's called structure nesting, and we'll get into that. But this is a simple selection structure, asking a question, making a decision, and doing something either way. And then a loop is where you repeat something over and over. So you ask a question, the answer is yes, you do something, and then you repeat until you exit. One programmer was reported to have died in the shower shampooing his hair. And there's, well, how could you die doing that? Well, the shampoo bottle's instructions were rinse, lather, and repeat. And so, anyway, jokes aren't very good, I know, sorry. All right. So that's called an infinite loop, and it'll just keep on rolling that way. But let's look at the sequence is pretty simple. I mean, that's just one thing after another. You've been doing that already. The selection structures, there are two versions of these. One of them on the left is called a single alternative. You ask a question, and if the answer is yes, you do something. And if the answer is no, then you don't do anything. You just move on. Whereas a dual alternative structure, either whether the answer is yes or no, something's going to happen either way. And I'll show you how you would write this in Free Basic here in a minute. But both of these are called selection structures here. Okay, example of a single alternative decision at the top. If the age is greater than or equal to 16, then print you can obtain a driver's license. So the structure looks like this. You have the word if, and then here is the question you're asking, and then the word then, and then an end if, and then whatever's in between lines 3 and 5 is called the body of the structure. So obviously there can be one line, there could be many lines, and it just depends on what you're doing. But the question is asked right here, and in this case, the question is the age greater than or equal to 16? If the answer to that question is true, then it comes into the body of the decision. This is line 4. If the answer to that question is false, it skips over line 4 and goes directly from 3 over to 5. So there is no alternative. If it's true, you do something, otherwise you just move on. But you look at the one below that, the dual alternative. If the age is greater than or equal to 16, you print out you can obtain a driver's license. Else, you print you cannot get your license yet. So in that case, you're doing something either way. And that's the difference. Really the difference is the word else right here. And you notice there's code in whether it's true or false, something's going to happen. So in the book, they show you their pseudocode, but the thing of it is they're not showing you Free Basic. They're showing you this sort of this invented thing that the author came up with. And I wanted to show you the actual code that you'd write, because that's really what you want anyway to do your work. So these examples are not in the book, but hopefully they'll make some sense to you here. And so, any questions about this so far? Okay, here's the obligatory shot of myself, right? That was fun. Okay, back. Loop structures. It repeats a set of actions based on the answer to a question. The diamond shows the question being asked. If the answer is yes, you do something, and then you come back up. The symbol has to look like this, meaning that the arrow has to come back up right above the diamond. You see that intersection right there? That's the thing that needs to happen. with a loop structure. So in the code on the right side, lines 5 through 8, that really is the loop structure. The stuff above that is preparatory to it. I create a variable called again as a string. This right here is called a priming read. A priming read is something where you have to set the condition true, even just to get into the loop. So notice the loops on line 5, and it says do while again equals y. And so it's going to do whatever's inside of the loop, which is lines 6 and 7. This condition is true. So what it's going to do, if again equals y, it's going to play a song, and then it's going to ask, would you like to play another? And it's going to read again, and that's going to either be y, well, who knows what the user is going to type. We want them to type probably a y or an n, and I didn't make that clear on this listing on line 7. You probably would want to say play another, and then say press y or n, so that they know what they have to do. But I wanted to just keep it simple. If they push y, it'll go down to loop. It'll come back up to line 5. It'll ask the question, is again equal to y? If it is, it'll repeat the whole thing. And at the end, it'll ask again. And if they keep hitting y, it will keep looping. Once they hit something other than y, it will come and ask the question, and it will no longer be true that again equals y. So it will fall out of the loop and come down below line 8, whatever comes next. So, but you notice if line 3 wasn't here, we would have line 1 where we created a string called again, and it would be set to nothing. And the loop condition is do the loop while again equals y. Well, if it got created but never got set, it would never even go into the loop to begin with. So this line 3 here is called a priming read. It primes the loop so that it will go through at least one time. So again, is forced to be y initially, and then it will go into the loop at least once, do what it's got to do, and ask to repeat. Now, if line 7 was not here, you'd have what's called an infinite loop. It would play the song, loop back up, and check again. And if you never asked inside of the loop if they wanted to continue, again would never be changed. So it would always be y forever, and the loop would run forever, or at least until you either hit Control-C, turned off the power, or used a large hammer, any of which work to stop the program. But that's the deal in an infinite loop. By the way, most computers that lock up when you're running a program lock up because of an infinite loop. So say you're running Microsoft Word, and I just had this happen the other day. I went to select some text, and I think I increased the font or something, and it just sat there with the hourglass, and who knows what it was doing, but it's an infinite loop. It's spinning its wheels doing something, and it's not breaking out. And so sometimes what happens is, you know how when you click a program and it'll say not responding? The problem is it's so busy spinning its wheels doing something, it's not checking the message system of Windows. Windows works with messages, and if you click something or move the mouse, it sends a message to the program saying, hey, the mouse just got clicked. Well, if it's so busy that it can't check its messages, then the messages start piling up. You ever notice when this has happened a few times to me, you hit print and nothing happens. So you click it 8 more times, and then all of a sudden, 10 minutes later, and it's always a document that's at least 20 pages long. It's never the one that's 1 page. So all of a sudden you get 20 copies of something, and that's kind of special. So what happens is it's busy doing something, and it's not checking its mail. And all of a sudden it finishes, and then it goes out to the mailbox, and there's 20 print commands sitting in the box. So it processes all those messages, and life is unpleasant. So then you're running for the printer trying to shut it off. But an infinite loop is where a program never gets out and it just locks up. And then, you have to shut it down with 3-finger salute, Control Alt Delete, or a large hammer, or the power, or whatever. So, anyway, infinite loops. But if the thing behaves right, this is how it's supposed to work. So, those 3 structures, sequence, selection, and repetition, all problems can be solved with those 3 structures. And what you do is you stack them. So you'll have some sequence code, and then you'll do a decision, and you can look at it like what happens with your flowchart is you'll have some sequence instructions, and then have a decision, and in here you may have a loop, and your program will just run and do its thing. But you've got sequence here, you've got selection here, and you've got loop down there, and they all, essentially you're stacking, and you have the sequence sitting here, selection sitting here, and the loop sitting down here. So you're stacking these things on top of each other, and that's when they say stacking, that's what they really mean by that. You're combining things together. So all logic problems can be solved with these structures. They can be combined in an infinite number of ways, and stacking them is when you put them end to end. How do you know when a structure ends? Well, if I go back to the loop, in Free Basic, you know when a loop ends when you see the loop statement. Now in the book they use, I think, end while or something, and that's fine, but in this language it's loop. And for an selection structure, the end of the loop of the structure is always end if. So you see it here and you see it down here. So I put those things down at the bottom of that slide. And here's an example. This is something that, what I did is I took their figure in the book, this is figure 3-6, and I replaced their pseudocode with my own pseudocode that looks a little bit more like Free Basic, just to make this more clear. You wouldn't actually write step A. Step A would be some type of an instruction, x equals x plus 5, or print something, or whatever it is you're doing. And step B would be another line of code. And condition C is some question you're asking. So, you wouldn't just type this in and it wouldn't work this way, but it's just trying to show you structure so you can see in the overall layout 2 sequence instructions, a selection, followed by a loop, and the code it would take to pull that off on the right side. Now, stacking is one option. Another thing you can do is something called nesting, and that's where you place one structure inside of another structure. So for example here, you have a decision structure, and if the answer is yes, you have a sequence structure. The sequence structure is nested inside of the selection. You can see that over on the right side. Here's another one. You have a decision structure, and then nested inside of it is sequence and a loop. So you're combining sequence, a loop, and more sequence, all inside of a decision. And obviously that makes programs work the way you want them to. So the question is, how do you know how to do something like that? And that's what we'll get to later. And then here's another one here. This is a decision structure followed by some sequence, and then you have a loop here, and inside of your loop you have a decision. So a decision inside of a loop inside of a decision. And obviously the number of combinations is infinite. These are just some examples. If you look on the right, you'll notice something kind of interesting here. I'm using indents to help me keep track of where things are. So you look at line number 1, it says if condition H, then, and the end if is down here. So everything between lines 1 and 11, all this stuff over on the right side. Notice step J comes first and it's indented over. I just hit the tab key and it just pushes it over. And then here is my loop. This entire thing right here is my loop. And it says do while condition M. That's this question here. And then if it's yes, I have a decision, which is represented by lines 4 through 8. See that? Again, I'm using indents. Every time I go out a level, I indent 5 characters or just a tab key. And then I come back the other direction when things shut down. So this is the end of the loop, which is here. And then here's the end if to close off this entire structure. So part of the challenge is learning how these things fit together and how they work. So, programming structures. You have structured programs and you have unstructured programs. Structured programs use only those 3 basic structures, and each of the structures has a single entry point and a single exit point. So if I look back here, here is the entry point for the decision structure right here. Here's the exit point. This is a sequence. Here's the entry, here's the exit. Okay, 1 entry point, 1 exit point. Here is a loop. I have 1 entry point, and this is the loop, and right here is the exit. How do you get out of a loop? If the condition is no longer true, the loop ends. So the no here would be considered the exit out of the loop. This fork off here is the loop itself. It's not exiting. The no is where you exit. So 1 entry point, 1 exit point. And down here you have this decision, 1 entry, and then right here is your exit. So as long as your program behaves itself and follows those rules, it's structured. Okay, we're going to look shortly at what an unstructured program looks like so you can kind of see the difference. But before we do that, we need to talk about this priming read, and I already essentially did this, but here's the formal place that it's dealt with. A priming read is where you set your loop up so that you can get into the loop at least 1 time. And so it's done outside of the loop initially to get into the loop. And they give you some examples of structured programs that do not use priming reads. So in other words, they don't really work properly. So you look at this program here. You start. You declare some variables, original number and calculated answer. You ask the user for the original number. Now, this term not EOF is sort of a generic term, and what it really means is, usually what it means is, does the user want to get out of the program or out of the loop? So EOF stands for end of file, and it's sort of a generic catch-all phrase, but here in this case we're not dealing with a file, we're dealing with a user. So usually what you do is you have something called a sentinel. A sentinel is something that they enter that signals the loop to stop. And it's usually something like, okay, if they're entering numbers, you want those numbers to be greater than -1. If they enter a negative number, we bail. So we're asking them to enter a number here, and if they enter something -1 or less, we fall out of the loop. So a negative number in this case would be EOF. So if it's not EOF, we go into the loop. If it's not EOF, that means the original number they entered is valid, meaning it's 0 or higher. So we take it, we multiply it by 2, we set it back to the calculated answer, we print that calculated answer out, and then we come back up and check if we've reached the sentinel, if we need to exit the loop. The problem here is that we have an infinite loop. And the reason we have an infinite loop is because we never bother to ask the user inside the loop for a new value. So let's take a look at what this would look like in free basic. If I was to write this here, open up free basic and just crank this one out. Dim original number, and I want to dim calculated answer. Input. I'm going to get the original number and then do while original number is greater than or equal to 0. So the condition for me staying in this loop is that the original number must be greater than or equal to 0. As long as it is, I'm in the loop. So if I'm in the loop, I want to take the calculated answer and set it equal to original number times, okay, it's doubling it, so it's times 2. Then I want to print out the answer is calculated answer. And so that is basically what we've got here in the slide. So if I run this program and I enter 8, got an infinite loop. You see it's just spewing out answers infinitely here. So I get the hammer out, which is Control C in this class, and we kill the program. So the problem is it gets the original number. If it's greater than or equal to 0, it goes into the loop, doubles it, and prints it out. Then it comes back up, and it says, is the original number greater than or equal to 0? Well, yeah, it still is. I started with 8, and it's still 8. And it will always be 8. So it never changes the loop variable at all. See, because I'm not asking for them to re-enter it. So what I need to do here is take this line of code in line 5, stick it down here. So I ask inside the loop. So now when I run it, it's asking me every time, and life is good. And if I say -1, I'm out of the loop and the program shuts down. So it's important to put your input statement inside, or you'll have an infinite loop. Never want to do that in a shower when you're washing your hair. Of course, like I would know. Okay, so this one is the priming read. If you don't put this in, you could have problems too. In fact, let me take a look and make a change to this program. Let's say that the condition was the number has to be greater than 0 in order to stay in. No big deal. So I'm 8, 4, 9, but if I'm 0, I'm out. Let's say that I don't have a priming read in my program. So what's going to happen? It's going to create this variable called original number. Since I've declared it, this is the declaration, but I haven't initialized it to anything. So the program will initialize it for me, and because it's an integer, it will initialize it to 0. So original number will be 0. Well, the condition here says that it has to be greater than 0 to go into the loop. So it's not. It's not greater than 0. It's 0. So it's never going to go into the loop. It'll skip over all this code, and there's nothing left, so the program won't do anything. In fact, if I run it, it just blips up there and goes away because it's not doing anything. So because it's missing that priming read. See, the priming read, now you might say, well, why don't you just set original number to 1 or something, right? That'll get you in the loop. Well, it will, but first thing it's going to tell me is the answer is 2. Well, I didn't tell you what the value was. How come you're giving me an answer, right? You don't want to set it to 1. You want to ask them what it is. So that's why we put this here. Yes?
What happens if you made the original number greater than or equal to 0?
Okay, that's a good question. Yeah. Take this back out. So if I make this greater than or equal to 0, it will go into the loop. You're right, and there's no priming read. But it'll come up and it'll say the answer is 0 because it assumes that's what the user put in, and when it gets into the loop, it assumes that you've typed in, you basically have set that value yourself as a user. So yeah, you'd still get that the answer is 0 there, and that isn't quite what you're after. So sometimes what you're saying will work. It's not always going to be this way, but like in this example, yeah, you have to put it twice. Now, this line of code here is the same as that line of code. One of the things that we try to avoid in programming is duplicating code because it's more of a maintenance problem. If you wanted to change this text message, right, it's in there twice. So you might, let's say it's something really trivial like change this to please enter. Nice. Problem is, if you change it here, you also want to change it there. If you forget to do that, the program won't crash and burn, but it won't show you the same message every time. So it's not really the best solution. And we talked about modules, last time, and this would be a place where a module would be helpful because you could create yourself a subroutine called get original number, and you could take this line of code here, put it into the subroutine, and of course if I do that I have to declare it like that, and then I have to make the original number a shared variable because I'm using it down here in the subroutine and I'm using it in the main program, so I need to share it with my subroutine. So I put the word shared up in front of the top of it there. And then I can take this line out and just call get original number, and I can do the same thing right here. And if I run this, it works the same way, but I don't have any duplicate code. Well, I have duplicate code as far as like calling the procedure twice. So you could say, well, that's duplicate code. Well, yes, but they're both calling the same thing down here. So if I needed to change my message, I'd only have to change it once, which is better, because then I won't miss it. If you have to change something more than once, it's more of a possibility that you might miss something. So this is a place where modules would be helpful to put into your code. So anyway, but yeah, this is the priming read. So if I was going to put a comment here, priming read. You were saying that these don't show up in the gray lines. Okay. Okay. Anyway, questions about that? this is an example of an infinite loop because they don't re-ask the question inside of the loop. This is an example here of something that works, but it's unstructured or spaghetti code. You say, what makes this spaghetti code? Let's take a look at it. It's similar. You create your two variables, and then there's this line 4 here, ask, with a colon after it. That's called a label, and it's sort of like setting a flag on the next to a piece of property and putting a name on it, right? And you write on the flag ask, and next to the flag is a plot of land. Okay. What you're saying is we're flagging line 4 and giving it a name. Well, that doesn't really do anything other than there's the flags, all right? So you continue. You input the original number, you go into the loop, you double it, you print it out, and then you see this go to ask. That will force the program to jump out of the loop up to line 4 and ask the question again. So what you're forcing the program to do is break out of the loop every time it goes in. So you go into the loop, you hit go to ask, you jump out, get your new value, and go back in. It works, but it's not well-structured code. It's whenever you see a go-to statement in a program, that's usually a bad sign, because what they're doing is they're jumping out of the loop or out of somewhere to go somewhere else in the program. And where that can get confusing is where you have all kinds of go-tos and things jump all over the place, and it's really hard to follow code that does that. You want your code, your structures, to be as pristine as you can get them. So I want to stay in this loop and just cycle through it. What I'm doing here is I'm jumping out every time. So it's not really efficient, right? And how do I know, by looking at the flowchart, that this is not structured? Well, let's go back and look at what a loop is supposed to look like. So let me erase this out. You ask a question. The answer is no. Exit the loop. If the answer is yes, you do something, then you come back like this. This is the critical piece to this is right here. Now, take a look again at the flowchart. Here's the question is being asked. Here is the stuff you're doing. And when it comes back up, it should come back up here to right above the diamond. But instead, it's going above that, and this guy's up in the way. So if I go back to my document here, the way it's been written is like this. And this is good. This is bad. But you have three kids, you start doing stuff like that all the time. Okay. It's really bad when you know all the Sesame Street songs and you know all the cartoons, and then you get these songs in your head all day long. It's crazy. Anyway, at least I didn't draw Barney or something. I have my limits. All right. Anyway, the diagram below, down here, is bad because when the loop body comes back up, it's supposed to come back up here. But no, it doesn't. It keeps going, comes up there. Whereas you look on this one, and it is structured properly. So that's how you can tell when you look at a flow chart if the thing is not structured right. And you can see here it's not structured right. That's how you can tell. Those three structures are very particular. They have to be set up and made consistent, and they have to follow that rule. So if a flow chart is not structured properly, and you try to write code off the flow chart, you'll end up with spaghetti code, or you won't be able to write the code at all. So the solution to that is to do your priming read here, and the loop, you repeat that instruction. See here that these two are duplicated, right? And I made that procedure to contain that, but it's duplicated, and the loop comes back up just above the diamond like it's supposed to. And then you know it's structured. And so that's how you could fix, if you saw that in a flowchart, that's how you would fix that problem, and you'd make it structured. So it's, whenever you sit down to write code, let's say that you say, look, these flowcharts are a pain in the neck. I don't like writing them. Why do I have to write these stupid things? Once you start writing programs for a while, you start to get better at it, and you don't really need to make flowcharts for everything you do. And so what you find is that your programs will naturally be structured by virtue of how you write them, and you're not going to have the situation where you're writing unstructured code very much. Once you start doing it, you start to learn how it works, and it's when you're starting out that this stuff's important to catch. So anyway, this is one example of how you'd fix unstructured code. Let's see what's going on here. Okay, this one is structured because the loop arrow points right up above the diamond like it's supposed to. But this is flawed because it doesn't have a priming read in it. And they've tried to do a priming read, but they didn't quite do it right. What they did is this. Inside the loop, they asked the question right away, which is good. Get the answer, output it, you come back up, and you get into the loop again. Well, what happens if the user says, look, I want out? So they push -1 for the answer. Well, it's going to calculate -1 times 2 and print it, and then come up and say I'm out. So it's not really an ideal solution. If I come back over to pre-basic and you say, look, I don't want to do this priming read. This is kind of annoying, so I'm going to get rid of it. And I'm going to put the get original answer like this. So I'll get into the loop, ask the question, double the answer, print out the results. Well, running it seems to work great until you want to get out. So you put -1. Now, I have to put a sleep statement in here so you can see what it's really doing. Right. It calculates and outputs the answer to the variable, the negative number, and then it exits the loop. So you're getting this print statement here as collateral damage, and then it's out. Well, the program would then continue to do more things, like print stuff or whatever, and everything's cool until the end there, and then this line of code right here is redundant, or it's not redundant, it's just something you wouldn't want to see. So it almost works, but not quite, not quite. Of course, what some people will do is they'll say, well, what if you put if calculated answer as long as it's greater than or equal to 0, then print it. So you would do this. So you wouldn't print out that answer if it was negative, right? So and now it seems to be working. It works, and you don't have a priming read above the loop. And the point in showing that is, look, you can make this work, but what you end up doing is writing extra code. You have here this piece of code here, actually this line and this line, which is 2 lines of code, could be replaced if I just put 1 line up here, right? So if I took the original number, I've got 1 extra line of code I stuck up here to fix it. And then I get rid of this, this. So I reduced myself from 2 lines down to 1. Well, big deal, right? In this case, it's a pretty simple program, but if you were going from 30 lines down to 15, that would be more substantial. So if your program is not well structured, you end up writing more code than you need to write. And it may still work, but it's just not as efficient as it could be. And we always like to have less code to get the job done. I was watching this Triumph of the Nerds movie over the weekend, and they were interviewing, I think it was Steve Jobs, the founder of Apple, and at the time when they first got rolling, IBM was sort of the king on the hill, and Apple went to IBM and Microsoft did as well, and they were both trying to work with these people because they both wanted to, their ideas to win. So IBM's thing was, well, the more code you write, the better the program must be. So, how many lines of code per minute can you write? And how many lines of code total does your program have in it? And the assumption was, well, the more lines of code, then the better the program must be. And he was just saying how crazy that was, because that's not always true. I mean, yeah, bigger programs probably do more, but if you have program A and program B, and they both do the same thing, and one takes less code than the other, that's good. But they never really understood that back then, that less code is a good thing if it works either way. And he's one of those things they were talking about. It was kind of interesting how frustrated they would get because of that kind of understanding of things. So, yeah, kind of interesting. But anyway, take a break here in a few minutes. I think we're about ready. But so there are ways to work around the system, but you're better off just building structure and right from the start. Structure gives your program clarity. It's expected as a professional software developer that you'll write code with structure, and if you write sloppy code, people aren't going to want to hire you versus someone else who writes well-designed code. And structured code's more efficient, less code to do the same thing. It's easier to maintain because there's not as much of it, and it's more clear. And it supports modularity, which you saw earlier. I was able to break things out into modules and reuse code, which is always a good thing. So there's a lot of benefits to structure, and we'll take a break here, and what we'll do next is look at flowcharts that are not structured and figure out how to make them structured. And then we'll talk about your assignment, and then we'll be done, and then we'll switch on over to the other room for those of you who want to go over there. So we'll take about 10 minutes and get back together. Okay, so we're going to pick back up where we left off and talk about structure for a while. And I have 630 more slides, so not too many left to go here, and we'll be done. So switch over to PC. Okay. By the way, obviously I'm desperate for some good material, so if you have any good jokes or references for that, let me know. Because I'm dying up here. Even with coffee, it's just not working. Unstructured code is spaghetti code, another word we use for it. It's logically snarled program statements, which basically means it's a big mess. And it works a lot of times, but it just isn't very easy to read. And it usually requires more code too, so unstructured programs don't follow the structured logic rules, and structured programs do. How do you recognize structure? If you're looking at code versus a flowchart, right? It's usually easier to recognize structured flowcharts because you look for those graphical rules. But when you're looking at code, you can always tell if it's unstructured when you see things like go-tos and other clues that you look for. Here's an example of a structured flowchart. And basically you look and say, okay, we've got a loop here. One entry point, one exit point. The line is coming back up just above the diamond. And on this end, down in this area, you have a nested structure. One entry point, one exit point. Life is good. This thing is structured. And that's really the process you go through to determine structure. Here's one here that is not structured. Okay, you have a sequence, one entry, one exit. You come down to a decision, one entry point jumps off in two directions and comes down in one exit, so that's cool. So far so good. Now when you come down to I here, one entry point, here's an exit over here. This one is not structured, and the reason is this decision right here, he jumps over into this guy's turf over on the left. He should come down and stay, you remember what it showed you. You had a diamond, and it would go up, over, and down, and then you do one thing on either side and come back together. He's not doing that. He's okay on this side, but over on the left side, he's jumping over to this other guy's decision stream over here. And that's a sign of an unstructured flowchart. How you determine that is, and the book gets into this spaghetti noodle thing where they start pulling on the flowchart and watching how things all pull apart. So they'll say start at the top and pull on. You take basically this line right here and you pull on it. And you pull it up, and up comes the G. And everything's cool so far, right? So a single process like G is perfectly fine. There's one entry, one exit. Then you come to the H, and you look at that, and you notice that there's no line coming up above it. So therefore, it must be a decision. Remember, a loop always has a line coming up back above it, but a decision does not. So H is a decision. No problem there. Then you pull on the left side, and it takes you to a J. That's fine. You pull on the other side, and you come up with an I. So far, that's all working right. Okay, now, back up a minute here. So, we pulled G out, we pulled H and J and I, and everything was fine. Now we attempt to pull K, and he's good. It's this left side of I where we have our problem. So let's take a look at this again here. This is all good so far. When we pull the line on the left side of the I, we end up coming over here. And that's a problem. So the solution to that is to take what it's pointing at, which is J over here, and duplicating it so that it looks like this. Now, so what I'm saying is when you have a flowchart that's not structured, to make it structured, you're going to have to duplicate things. So the J is going to show up twice. And that's intuitively going to seem odd because you're like, well, why would I want to duplicate something? That seems like that's not good to have to duplicate. And ordinarily that would be true. However, we would take both of these J's and we'd put them off into a module and call that module. So any common code we would do that with. And that's usually how you resolve that issue. These things all come back together at the bottom. Now, you look at this flow chart. G has an entry and an exit. H, one entry, decisions either way. They come back together at the bottom with one exit. I has an entry, forks off either side, comes back together, and there's one exit. And again, that's a sign of a structured flow chart, and that's what you want to be able to see. And so, in order to do this, you need just to practice a lot with with these flowcharts and experiment, and it usually involves cloning or duplicating pieces of the flowchart for them to come together. So, we'll look at a few more examples, but just to summarize where we are here, you've got three basic programming structures: sequence, selection, and loop. Those are the only three things you need to write a program, and you combine them in different combinations. You stack them, you nest them, you do whatever you got to do. When you do a loop, you need to watch for priming reads. Make sure you do that in a loop structure. And then you want to make sure your flowchart is structured for clarity, professionalism, efficiency, modularity. Spaghetti code is evil. You don't want to do spaghetti code. And you can make a flowchart structured by untangling it, which the book spends quite a bit of time doing. Let's take a look at, back here to the top, this flowchart right here. And let's write the code to mimic this thing. Right? So what I'm going to do, I am going to draw this on my whiteboard so I can keep track of it here. E, going off to E. So I'm going to write a program that simulates this flowchart. And this is in your book. It's figure 3-20, right? So that's where I'm at here. So I'm just going to switch over to free basic, and I'm going to write this thing. Right. So I have D, E, F. D, E, and F. Okay, so now F is a statement. D and E are questions. So I'll start with if D greater than 0, then E is greater than 0, then F equals 10. Let's see, I'm going to see if I can put these two together here. So if you look at this structure here, first thing the program does is it asks a question. Is D true or false? Now, I made that a little different by saying is D greater than 0. I have to have some question I ask about D. So I'm going to ask, is it greater than 0? If that's answer to that question, you know what? I didn't do this right. On purpose, of course, just to show you why I did this wrong. You do get extra credit for laughing, by the way, and I should have mentioned that before. I've got a little list up here, and so far nobody's taken me up on it. You're like, yeah, whatever. Okay, so notice I wrote this as an if-then statement. Not a good idea. Why? Because I have a situation where this arrow is coming back above the diamond, and that signifies a loop. So I need to make a change. Actually, I'm going to try something different here. This. Let's see if I can move him over a bit. Okay. So on line 7, instead of D being an if statement, it's a loop. Do while is greater than 0. And at the bottom, I have a loop. So my my outer structure is a loop. And so while the loop condition is true, I'm going to do this if statement. If not, I'm going to break out of the loop. So that's the correct way to write that diagram out. And obviously I did it wrong on purpose to show you. And I see I even repeated the joke. I gave you an opportunity there. It goes back to itself. You always know it's a loop when it does that. That's a dead giveaway. And so it's structured. Everything's cool on that one. Questions on that? Is that making sense? Do you kind of see the connection? I know it takes a while to think through these things, but what else have we got here? This one. This one is not structured, so how would I go about doing this one? I want to take, we've got G, H, I, J, and K, so I'm going to this is for figure, whatever this is, 3-21. So we've got G, H, I, J, and K. And so I need to bring this down just a little bit. So the first thing I see up here is this G, whatever that is. I'll just say G equals 0, right, 'cause it's just for fun here. Now here we have a diamond, so this could either be a loop or a decision-making structure. Since nothing comes back to it, above it, it's a decision-making structure. So I would say if H is greater than 0, then, and then whenever you put an if in, you always close with an end if. So that takes care of H. Now if the answer to that question is no, I do J. In an if-then statement, the part that's the no part, the no piece, is handled by the else, right? So you have if, then you ask your question, and then a then, and then on line 12, this is the code for yes. This here is the code for no. Else piece is the code for the no answer to the question. And I'm just saying J equals 0, because whatever, doesn't really matter what I do on this. Now, if the answer is yes to the question, that takes us over here. Now we have another diamond, and this one doesn't have anything coming back above it, so it's another question, the selection structure. So notice I've indented my code, and I'm now going to say if I is greater than 0, then do K, else. Here's where we have our problem. If the answer to I is no, we have to come over here and do this J step. Well, where is the J step? It's down here. Now, we're sitting right here. And what we really need to do, if I greater than 0 is no, we need to come over and do J. I greater than 0 is not true. We go to our else. Right here, we really need to be here. So here's the issue. We are sitting here, and we really want to be down here. How do we get from one place to the other? That's the issue. On a flowchart, it's simple. You just draw a line over to the place, and you're done. But in code, it's not. How do you get from this over to the other place? Well, we can cheat and put a label in here. Say go to here. That would work. That would jump. When it says go to here, it would jump down to this line. It would basically force it out of this decision structure, force it down into another decision structure out elsewhere, and that would work. But you can see that the problem there is it's not structured. It's confusing. It's jumping out of its own if-then statement into someone else's if statement, and that's what we want to try to avoid. Well, how do we solve this problem? If you look at the flowchart, the way they solved it was they put, go down to where they did this. They went like this and put, now there's one more step. Here we go. They duplicated the J. So they took this J, duplicated it like that to get this to work. Now it's structured. It's structured. We have the same line of code in here twice. As you can see in the flowchart, it's also in there twice. So we're duplicating some code. And again, the way that we could solve that would be to take this line of code, put it into a subroutine, and have both places call the subroutine, and that would avoid that problem. Or you just duplicate the code and don't tell anybody, and then you're fine. So, but that's the way that you would solve this. Now, if you were just writing this program without doing a flowchart first, you would probably write it in a structured way without even thinking about it. And then if you went to do the flowchart, it would be fine. And so that's usually how it ends up happening is you build, if you just write the code yourself, it ends up usually being structured. If you end up putting go-tos in and things like that, that's usually a sign that it's not structured. It may still work, but it won't be the best solution. So, that's just an example of how to handle something like that. And any questions on that? Okay, it's time for the obligatory mugshot. Watch for the glare. Okay, here we go. All right, now one thing I wanted to talk about when you're doing, let's see, I got to go back here to flowchart with a loop in it, like this one right here. Let's say you were going to build this in Visio. Okay, so my Windows key, where am I here? Windows, okay. Out. I want to build this thing in Visio, so I'm going to fire up Visio here. And where is he? Office, Visio, and I would, when this thing opens up, I'll choose Basic Flowchart and zoom this to with the page. Scroll up just a little bit, and this is what I'm after. So I want to start with a decision. The D equals, and then to blow this up here. Okay, if the answer is no, then I just come down. So I'm going to draw a line that just ends down here. Now, if you want to put no next to a line, you click the text tool up here, and you can put the no on the line, which is actually, oh, that worked like a charm, didn't it? Oh, I think I know what I did. You have to click on the thing and then draw a box where you want to put the text, and then type it in. So you draw your line, you click the text tool, but if you click it once, it wants to put it right in the middle of your line, so I'll hit escape. And instead I'll click the text tool and draw a box above it, and then I'll type the yes. So you might have to play around a little bit with Visio on that, but ultimately you're going to want two text boxes that you can then just move around. So I can alter position of this thing. I'm going to get them closer to the lines. You can do that. The idea is you want to click and just use your arrow keys. Now if it starts to blend over, it wants to push the line like that. Then you can just take the drag handles and make it smaller. Again, it's just sort of trial and error. Just play around with it. Now, if you're really picky, you'll sit here for hours trying to get it just perfect. But I would never do that. Okay, yeah, I do. Anyway, that's because I'm not normal. Back to the diagram. So, if the answer is yes, I have another decision structure here. So I want this connector to go here, and this is the E question. So E, and let's see. Then there's a yes or a no on that one. So I put process over here. That box is way too big, so I'm going to knock him down to size a little bit. Put him here. Put an F there. Draw the lines between two. That. And now, on this side, the no wants to connect down here. So ultimately, you want him to come back up here. And this is where Visio starts to have some issues. I need to put a line like this, kind of my starting point. Oops. Look back at the original diagram, there's a line up here, right? It's, okay. On the E branch, I want to connect it probably right about here. And the F branch, I want to connect like this. But it's going to want to put arrows and stuff in here, right? Now, one way to deal with this is to put a connector in, and the connector, usually we just use a circle for this. Just looking to see if there's any other symbols. I guess that would be, take a circle and make it small. Oops. Stick it right there, and I'm going to take these lines and hook them to the sides. That. I'll make the circle even smaller. And then I can take this connector, and as I adjust the connector, it will move the lines with it. And that's just a nice, easy way to set these things up. The arrows, now if you don't want those arrowheads on there, you can click on the line, and up at the top here there's this line ends button, and you can say no line ends, this guy, and say no line ends. Get rid of those arrows, and you could technically even take this out and hook the two lines together if you wanted to, but certainly if this makes it easier, that little connector is fine to put in. And the size of it doesn't really matter too much. Now we want this to come back up here. Now, problem here, let me make this a little bit smaller. The problem here, if you try to take and draw a line from here up to here, it wants to kind of place itself over everything else, and sometimes you have to massage that line a little bit to get it to work. And then you can see it lines it up. If you have issues up here, you can put another connector circle up in here and hook them together there as well. Usually this is okay. It's this kind of stuff here that it gets a little bit touchy, and I'm going to see if I can make this circle small enough. Yeah, I can make it so small that it almost doesn't even show up. Of course, if you do that, it's pretty hard to work with. So it's probably, you want to be able to see the little X's around the edges so that you can hook things to it, right? But you can play around and try different things out. But that's usually how I hook together things on flowcharts. A lot of it's just trial and error to get things, play around until you can come up with something that works. So as you start to do decision making and stuff, you'll be running into some more of these kinds of issues. So, any questions about that? Okay, that's painful. Let's go back. Okay, let me go back then to the blackboard, and let's talk about assignment for chapter 3. Okay, like all the assignments, it's worth 100 points. There are 3 case problems, each one is worth 30 points. And then there's 10 points for the submission, like we always do. There are 3 case problems, and this first one, case problem 7, has you going to page 128 in your book. And there are 5 flowcharts in there that you'll notice in the diagrams. Some of them are more complex than others, but none of them are structured properly. And so what you're going to need to do there is look at the flowchart and rewrite it so that it's structured. And then once you do that, write pseudocode to imitate the flowchart. Now the pseudocode doesn't have to be something that you would actually run in free basic. So for example, if you're going to do pseudocode, it could just be something like this. Step A, do while, condition B, step C, step D. Right? So when you look on the diagrams and you see a letter, you could just write D, or if you want to say step D, that's fine. Something like that would be fine. If it's a condition, so if it's inside of a diamond, I usually will write condition B instead of just a B. But anyway, it's just pseudocode, so it doesn't actually have to run. But they just want you to actually write the pseudocode that matches the flowchart. And you should be able to do that. Writing pseudocode for an unstructured flowchart is really tough. You have to use the go-to statements, and you'll know if it's not right, because things just won't fit together the way you want them to. So for each flowchart, you'll redesign the flowchart and write the pseudocode, and redesigning the flowchart is worth 3 points. Doing the pseudocode is worth 3. That's 6 points times 5 flowcharts is 30 points. Pretty impressive, and I stayed up till 2 last night doing the math on that one. Okay. So that's the first one, and you'll have 5 different parts to this thing. So I just had you label these CP7A, 7B, 7C. So when you put together a Word document, just label them that. So you'll have a CP7A, then you have your flowchart, and then you'll have your pseudocode next to it, or however you decide to do it. So that's case problem 7. On case problem 8, you have a program to write. The company has a payroll department that prints checks out for its employees every week. And you're going to write a program that calculates the employee's paycheck. The specifications are that if you're an hourly employee, you get your base pay plus time and a half if you work overtime for 40 hours. If you're a salaried employee, you take their annual salary, you divide it by 52 to get the weekly salary, the weekly amount, and that's how much they get, no matter how many hours they work. So the program is going to ask the user if they're hourly or salary, how many hours they worked, what is their pay rate, and figure out what their take-home pay is. We're not taking out taxes and all of that. It's not fun the way it is. So there is no one way to implement this. I mean, it's not like there's one perfect way to do it. So it's up to you how you want to build it. But create a flowchart, and the flowchart should be structured, and then write the code to accomplish the objectives. And, so you have a flowchart, you'll have a free basic program, put them together, and that's case problem 8. And then finally, for 9, if you're going to be taking an existing block of code, and you're going to design a flowchart based on that listing, and you're going to find that the flowchart is not properly structured when you do the flowchart based on the code. So first thing you'll do is you'll look at the code, you'll make a flowchart from the code, you'll see that it's not properly structured, and you'll redesign the flowchart so that it is. That's step B. So step A is building the flowchart from what you see now. Step B is taking that flowchart and reworking it so that it's structured. And then step C is to rewrite the program so that it's structured. And if there's any duplicate code, put them into a module and call the module, sort of like what we did in the video here, or the example tonight. This program, it looks to see what a movie rating is, and if the customer is less than 18 and the movie is rated R, then it doesn't let them get the ticket. If they're under 18 and the movie's not R, it's $8.50 for the cost. Unless they want to purchase a premium box seat, then it adds $3.50. I don't know of any theaters that have premium seats around here, but it was 2 in the morning, not enough coffee at that time of day. If they are over 18, they pay $12.50 a ticket, and then $3.50 again if they want a premium upgraded seat. And then it prints out the cost that they owe, or it tells them they're under the age limit, and then it asks to repeat the process. So what you'll want to do on this one is take and look at the code and make a flow chart out of it, examine that flow chart, redo it so that it's structured, and then rewrite the code. You only should have to alter a few things in here to make it structured. It's not like you have to totally rewrite it, but that'll give you some practice doing that. And so at the end of this one, you'll have 3 things. You'll have the unstructured flowchart, which we're calling CP9A, structured flowchart CP9B. The program is just CP9. So when you do your document, just label them those, and you should be fine. And that's it. So when you go to submit it, zip everything up and do a printout like you're doing now. So this guy is due on the 17th of June, so it's the schedule here. So we're talking 2 weeks from today, basically. So next week, and tonight as well, we'll have some time. On assignment 1, that was due on the 20th. I have the solution out for that. So if you go to Learning Units, Chapter 1, it'll say Chapter 1 Assignment Solution, and there is a PDF document there which you can open up and see compared to what you have already done. And I'll continue to do that as we go, so you have the solutions. So you can compare to what you've got. I have to wait until the late deadline is passed before I can put them out there. So I'll continue to put them out for you. So anyway, that's pretty much it for me in schedule and in material. And so what we'll do now, did everybody fill out the attendance sheet? Everything's good? Okay, I'll get it from you in a minute. So we're good there. And what we'll do now is just head over to the other room, and I'll continue to help you over there. So, all right, thanks.